So now we're on the back side. So the 15 through 17 just want us to state the slope of the line that's parallel to each. So parallel lines are going to have the same slope. So like for 16, I'm going to skip this one because it's a little bit more difficult. But 16 is pretty easy. Okay. Slope is 5, so the slope of a parallel line would be 5. For 17, okay, so remember on the front side we were doing that thing with the Hoy and Bucks. That applies again here. So when you have an x equals line that goes with the Bucks, which means it has an undefined slope. So a parallel line would also have an undefined slope. Okay, now for 15, we need to rearrange this equation and get it out of standard form and into y equals form. So let's do that here. Okay, so I want to subtract 5x from both sides. So I get 7y is equal to negative 5x plus 15. Divide by 7, and we get y is equal to negative 5/7 x plus 15/7. So our slope is negative 5/7. Okay. For 18 through 20, now it wants the perpendicular slope to these lines. Okay, so our first question is a y equals equation. If you remember our Hoy, Bucks, a y equals equation has a slope of 0. Perpendicular to a slope of 0 is an undefined slope. Okay. For number 19, we're going to, let me get out my paper. So we need to rearrange this again. So we're going to subtract 5x, so I get 6y is equal to negative 5x plus 18. Divide by 6, and we get that our slope is negative 5/6. Okay, really this doesn't even matter, but there you have it. Okay, so negative 5/6 would be our slope. All right, we want to get this out of standard form again. Okay, so we're going to subtract our x, so we get negative 7y is equal to negative x plus 15. Divide by negative 7. Okay, y is equal to a negative divided by a negative becomes a positive. So that's going to be 1/7 x. And then this is whatever, because it doesn't really matter. All we need is the slope. Okay. Next it says to write the equation of the line that is parallel to 5y plus x equals 12 and passes through the point 5, 5. Okay, so this is going to be kind of a two-step process. We first need to convert this to y equals to figure out what's our slope, and then we need to get our equation. So I'm going to start by subtracting x, so I have 5y is equal to negative x plus 12. Divide by 5, and we get y is equal to negative 1/5 x plus 12/5. So this is what's important. This is what I want from that equation, is that slope. Okay? So for my line, my slope is going to be negative 1/5. Hold on 1 minute. Okay, sorry for that little interruption. So let's see. We got our slope, we have our point. Now we need to get our equation. Okay. Oh, wait, no, this is parallel, so it should be the same slope. Okay, good, we're good to go. Okay, so personally for me, I like to use point slope form and then convert that into y equals form. So that means that we're going to do y minus y1. Our y1 is negative 5, so that becomes y plus 5, since we're subtracting here, is equal to negative 1/5 times x minus 5. Okay? So the reason I kind of like this method is because you can get your y equals in 2 steps. First, you just distribute. So negative 1/5 times a negative 5 gives us 1. Okay? So we're going to have y plus 5 is equal to negative 1/5 x plus 1. Okay? And then subtract 5. 1 minus 5 gives us negative 4. So my final equation, y equals negative 1/5 x minus 4. Okay, so 22. We've got the equation 3y plus x equals 17 and passes through 5, 5. We want to be perpendicular to this equation. So we need to get our slope first. All right, so I'm going to start by subtracting x. So we've got 3y is equal to negative x plus 17. Divide by 3, y is equal to negative 1/3 x plus 17 thirds. Okay, now our original slope is negative 1/3. We want to be perpendicular, which means we need to do the opposite reciprocal. So that becomes 3. Okay, so now I want a little bit more room to work. So I'm going to use my point slope form. So I'm going to have y minus a negative 5 again, so it becomes y plus 5 is equal to 3 times x minus 5. Distribute. So we've got y plus 5 is equal to 3x minus 15. Subtract 5. Y is equal to 3x minus 20. Okay. All right. 23. Write the equation of a line that is parallel to the line that passes through these points and passes through that point. Okay, so for this problem, I would recommend creating a table. All right, so we have 3 points here. So we've got x and y. We've got, parallel to the line that passes through these points. Okay, so this is how we're going to get our slope. Okay, and then we need to use this point to get our equation. Okay, so to get our slope from 4 to 14, that's adding 10. And from negative 3 to negative 8, that's subtracting 5. So slope is change in y over change in x. So in this case, that's 10 over negative 5. 10 divided by negative 5 is just negative 2. So our slope needs to be negative 2. And then the other part of this problem says that we need to pass through the point negative 10, 5. Okay. All right, since I did the point slope method on this one, I'm going to show you a little bit different method here. So we know that we want our equation to be in the form y equals mx plus b. So another way that we can solve to get this equation is by plugging in the points, the coordinates x and y, and plug in your slope and solve for b. So for example, my y is 5, my m is negative 2, my x is negative 10. Okay. And now all I have to do is solve for b. So negative 2 times negative 10, that becomes a positive 20. Okay. Subtract 20 from both sides. 5 minus 20 gives me that b is equal to negative 15. So my final equation would say y equals negative 2x minus 15. Okay. Sorry, I'm getting another scratch paper to work with. Okay, now we want a perpendicular line that passes through 0, 0, and 4, 1, and then through the point negative 3, 6. So just like the other problem, we're going to start off with our table. Okay, so we've got 0, 0, 4, negative 1, so that's going to be negative 1 plus 4. So our slope is equal to negative 1/4. Now we want the perpendicular slope, so when you do the opposite reciprocal, that becomes a positive 4. Okay, so I want to show you one other kind of method for solving for your equation, and this is the process table method. Okay, so what happens is that we create a chart with an x and a y, and then in the middle, this is where we're going to figure out what does that equation need to look like. So on the x we have negative 3, and on the y we have 6. We know that our m is 4, x is negative 3. We need to figure out what does this plus b need to be. Okay? So 4 times negative 3 is negative 12. And we know that, what am I saying? So when we're doing an equation, what it means is that when you input negative 3, it's supposed to output a 6, which means that when we plug in negative 3 for x, if we're doing this equation correctly, then we should end up with 6. So the question now is what plus b do I need to have in order to get from negative 12 to a positive 6? So in order to get, so let's see. Okay, so one of the ways that we can think about this is using subtraction. Okay. So if I subtract negative 12 minus 6, that gives me negative 18. But negative 12 minus 18 isn't going to take me to 6, so I need to add this. Negative 12 plus 18 is what will get me to positive 6. Okay, and that's how I know what my plus b is. So now altogether, y is equal to 4x plus 18. All right. 25. What is the equation for the perpendicular bisector of LM? Write your answer in standard form. Okay. Okay, so a perpendicular bisector does two things. It's perpendicular to this line, and because it's a bisector, it's going to go through the midpoint. So first we want to get the midpoint for this. I can kind of eyeball it, but then check my work because I'm going down 3 over 1, down 3 over 1. So it should be the same on both sides. Okay, so my midpoint is equal to 3, 5. Okay. My slope for LM is equal to, so when we count our rise and run, we're going down 3 over 1. Okay. So our slope is negative 3. All right, if I'm perpendicular to negative 3, then the opposite reciprocal slope is going to be a positive 1/3. Okay. Goodness, sleepy. Okay. All right, now we want to get our equation. So it's going to be a lot like these other problems. You can use any method you want to. I'm going to use point slope method. So I'm going to have y minus 5 is equal to 1/3 times x minus 3. Distribute that out, so we've got y minus 5 equals positive 1/3 x. And then 1/3 times a negative 3 is just negative 1. Add 5, we get y is equal to 1/3 x plus 4. Oh, that's right. But part 2, it doesn't want it in y equals form, it wants it in standard form. Alright, so now we got to take this equation and we need to convert it to standard form. Okay, so standard form is an equation written in the form ax plus by equals c. A, b, and c need to be integers, and a needs to be positive. So we're going to start by getting our x on the same side as y. We do that by subtracting from both sides. So we're going to have negative 1/3 x plus y is equal to 4. Okay. Now I need to do two things. First, I need to get rid of this negative, and second, I need to get rid of this fraction. Okay. So I can get rid of the negative pretty easily by multiplying everything times negative 1. So that basically just means everything is going to switch signs. So that becomes positive, that becomes negative, and that becomes negative. All right, I can deal with the fraction by multiplying by whatever's in the denominator. If you multiply 1/3 times 3, it's equal to 1. The 3's cancel. Okay, now because it's an equation, you can't just multiply one thing by 3. You have to multiply the entire equation. So this becomes 1x minus 3y equals negative 12. Okay, and that's my final equation in standard form. So I don't have much room here, but it would be x minus 3y equals negative 12. Okay, what can be said about the point 6, 6? All right, so I have a feeling that this question has to do with the perpendicular bisector theorem, which makes me think that it would be a good idea for us to plot this perpendicular bisector on the graph. Okay, so if we're going to plot this, it starts at the midpoint. We know it has a y-intercept of 4, and it has a slope of 1/3. So we would go up 1 over 3, up 1 over 3, okay, up 1, 2 over 3. Okay. All right, let me connect those. There's our perpendicular bisector. Okay, now, if you look at the point 6, 6, which is right here, this is a point on the perpendicular bisector of LM. So this question, it is contained on segment LM. That's not true. It's the midpoint of LM. No. Then we're left with either nothing can be said about it, or it's equidistant from points L and M. And this is what we wrote right here. When we look at our perpendicular bisector theorem, that's what that says. Any point on the perpendicular bisector is equidistant from the endpoints of the segment. Okay. Almost done. The bell's probably going to go off here in a second, so just ignore that if you're sitting in class. So 26, in the rectangle to the right, opposite sides are parallel and adjacent sides are perpendicular. Given the equations for 3 sides, what could be the equation for the line of the fourth side. Ooh, and it wants it in standard form. Okay. So we have that these sides have a slope of -1/3, and this has a slope of 3. So what that tells me is that this side right here is going to need to have a slope of 3. Now, as far as the y-intercept goes, I don't believe, since we're not on a graph here, we don't really have a good way to find out exactly what that could be. I believe that's why it said what could be the equation and not what is the equation. So I would guesstimate, since this is y-intercept is 10, so this is intersecting somewhere around there. This y-intercept is -3. I don't know. I'm just going to put +2. I don't think it really matters though. Okay. All right. Now what is important is that this slope should be 3. That's what should be consistent throughout everyone's answers. All right. We want to write this in standard form, which means that we need this to be on the other side. So I'm going to have to subtract 3x from both sides, so we get -3x plus y equals 2. Problem, a has to be positive, so we need to switch all of the signs in this equation. Okay, now if this were a test question and you had multiple choice answers in standard form, again, the y-intercept isn't really what's super important, but it is important that if you're solving this equation for y, whatever you get, your slope should be 3. Okay, last two. All right, so we've got some algebra problems involved here. So it says, given that Q is parallel to T and the measure of angle 3 equals 12x plus 4 and 8 equals 10x plus 10, we want to find all these different angles. Okay, so what we know about 3 and 8 is that these are corresponding angles which are congruent. So I'm going to solve this by setting these equations equal to each other. Okay, so minus 10x, 2x plus 4 equals 10. Okay, subtract 4, 2x equals 8. So that gives me that x is equal to 2. All right. Now, once I know that x is 2, I can go plug this in, okay, to get what these angle measures should be. So 12 times 2 plus 4 is equal to 28. So that's the measure for angle 3. Okay. This should be the same since we set those two things equal to each other. So 10 times 2 plus 10. Wait a minute. Sorry, I'm rushing now because I have to get to a meeting, but where did I mess up? So I must have got the wrong x. No. Let me pause this until I can figure out my mistake. Found my mistake. 10 minus 4 isn't 8. that's going to be 6. And I divided by the wrong number. Oh my goodness, I'm making all kinds of mistakes. Okay, so up to this point, we did everything correctly. So 2x plus 4 is equal to 10. Okay, then we need to subtract 4. So 2x is equal to 6. And then divide by 2. And we get x is 3. This is what happens when you rush. Make silly mistakes. All right, so let's take this out. Let's fix this. Okay. That's wrong. Okay, so 12 times 3 plus 4 is equal to 40, and 10 times 3 plus 10 also equals 40. Okay, there we go. That's what it should look like. So these are both 40-degree angles. Okay. And now the last thing, to get angle 2, once we know angle 3, we know that 2 and 3 are a linear pair. So 180 minus 40. Oh, here I'm going, making mistakes again, is equal to 140. Okay. All right. Last problem, and thank goodness, because my brain is dying. Okay, last problem. So we're given that Q is parallel to T. We know that the measure of angle 1 is 6x plus 13, and 7 is 8x plus 17. I need some clean paper. Here we go. Okay. All right, 1 and 7. These are same side exterior angles, which we know to be supplementary. So we set up this equation by saying 6x plus 13 plus 8x plus 17 is equal to 180. Okay. 6 plus 8 is equal to 14x. Okay. Combine 13 and 17, and that's equal to 30 is equal to 180. Subtract 30. 14x is equal to 150. Okay. Praying I haven't made a mistake here. I feel like I have though. Maybe it is supposed to be a decimal. Let's just double check this. Okay. So 6 and 8. Yep. Yep. 80 minus 30. 50 divided by 15. Okay, so x is equal to about 10.7. Now, let me double check this answer to make sure I haven't made a mistake. So if this is true, then when I add 6 times 10.7 plus 13 plus 8 times 10.7 plus 17, that should be equal to 180 if I've done everything correctly. So let's see, 6 times 10.7 plus 13, that's roughly 77.2. Okay. This is roughly 102.6, which is roughly 180. Okay, so that's good. I'm satisfied with that. So we've got x is about 10.7. We've got angle 1 is about 77.2. Angle 7 is about 102.6. The last question, if this angle is 77.2, 3 and 1 are vertical, which makes them congruent. So those are the same. Done. All right, y'all. Good luck on your test tomorrow. I wish you the best.